Well, Monday's here again, and I've got some. I ran across looking through my archives, and I ran across some stuff I could talk about that I thought was pretty good. I got a few stories here to tell, and I basically launch into them with pictures. And so here we go with photo number one. You know, most everybody, if you look around, has got all kinds of pictures. They can tell you about brakes that weren't fixed right, and you know, I mean, the most common one that you see is where people put the brake pads on with the metal part of the pad pointing toward the rotor, and they can destroy a rotor that way. And I think I've mentioned that before, but I have seen people that have done really good, solid brake jobs the right way repeatedly when I was training them. You know, and some things you've known so long when you're an instructor that you feel like it's common knowledge to everybody, like which way lug nuts go on. You don't put the open-ended lug nuts on backwards with the tapered side out, but it always amazed me how people would do that. I do not remember being in a position, I don't remember how young I was when I learned which way to put lug nuts on, but I do remember, you know, knowing that the tapered side went in for as long as I can remember. Anyway, this pad right here was put on there, not with the metal side toward the brake surface, but they managed somehow to get it in there so that the curved side, this curved side right here that was supposed to go out there, wound up in here, and it was scrubbing on the hat, which I thought that was kind of novel and original, but occasionally somebody does something like that. I have actually seen, there was a Jeep one time that we worked on that had some kind of a funky noise, and he had just had brakes put on it. Couldn't find anything wrong with the brakes, but it would make a noise, you know, whenever you were driving it. And we wound up just putting a different set of brake pads on that one and straightening it out. Sometimes it's as simple as that. This right here is something that happened. It seems to be more common on circuits, on the highest current circuits that run all the time on the car. And I'm not talking about the starter because it doesn't run all the time. The highest current circuits are the ones that are typically the fans, whether it be the radiator fan or whether it be the fan in the car, and these blower resistors, you know, the terminals begin to oxidize, and whenever they begin to oxidize, they gather resistance, and when they gather resistance, they start to build heat. When they start to build heat, they oxidize the terminals a little more, snowballs out of control, and then by the time somebody says, well, I have to slap under the dash to get my blower to work, you can count on finding something like this when you get under there. Now, this can also happen under the hood on the blowers. And also, I had a picture shown a while back, a couple of times, of a fuse that was feeding the fan, like a 60 amp fuse, and it had burned because it didn't blow the fuse, but it basically got it hotter and hotter until the current wouldn't flow. And whenever you pulled it out, you see that it had done a melt job on that. So it's going to find the place where there is some resistance, and then it's going to begin to get hot. When it begins to get hot, it oxidizes the terminals. Now, the way I combat this, when I fixed one, we're going to replace the resistor, and we're going to replace the pigtail. We're going to make sure we solder and heat shrink the connectors and get the wires in the right positions and all that. But I like to put that silicone dielectric grease on it, the Motorcraft stuff or any other kind you have, so that it will actually prevent the oxidation from taking place. That grease keeps that oxygen from making it, you know, and it doesn't prevent current from flowing. The dielectric grease doesn't have any conductive properties, but it also doesn't, I mean, it keeps air and moisture out of there and oxidation and that kind of thing, so you don't wind up in a situation so you've got all this business going on where you've got your terminals, you know, scorching and oxidizing like that. Anyway, when I fix something like that, I don't like to just fix it knowing that it's probably going to come back later with a similar problem. We did have one time a Buick Rendezvous that came in there, and it had a scorched terminal going where the pin was leaving the underhood junction box going to the fuel pump, and the fuel pump wouldn't run. We went in there and we found out it had a brand new fuel pump in it already, and so we went ahead and went to we caught it in a position where the fuel pump wouldn't run, and we pulled the relay, got the test light, hooked it to hot, touched it to the pin that was leaving the relay going to the pump, and on that one, that was a straight shot. I don't remember what year model it was, but it was in the early 00s. And what we found on that one was there was a terminal that had scorched and burned under there for this same reason, going to that fuel pump. Volkswagen had trouble with that back in the 80s on their Volkswagen Rabbits. They just had one little pin. You know, I don't know if you remember any of those fuse panels, but they had these cavities with a bunch of pins in there. And the pin that fed the fuel pump was pin A8. And that thing couldn't handle the current. Now, some modules will have two terminals with heavy wires coming from both of those terminals. It's basically two of them running in tandem out to a heavy load, to try to prevent this kind of thing from happening. But one way or another, that pin A8 was a bad thing, and also the one on that Buick, we wound up having to replace the underhood fuse box and put a new terminal on there to fix that problem. But that terminal was a little bit too small to be carrying that fuel pump all the time, because the fuel pump's going to pull 8 or 10 amps whenever it's pumping a lot of fuel. When I say that, usually it's 4 to 8 amps when it's pumping fuel ordinarily, on a pump, on one that's just got a relay that closes and drives the pump. But anyway, this kind of problem, once you fix it, we had to do, there was a recall program on those Volkswagens that would quit running because pin A8 burned out in the fuse panel. We had to go around that. And then we had the vans, the Ford had the vans that we had to actually put a circuit breaker in the fuse, cut the wires loose from the fuse box. This was a Ford fix, and put a circuit breaker in there rather than have the fuse go through there, because them old glass fuses on those vans, it would just melt the solder out of them and the van would quit running. But anyway, that's really got to be a very robust circuit on something that's going to be running all the time, under that hot hood or under there, where anything like that that's carrying current a long time is going to start to warm up. All right, what you got right here, look at that. You have a clutch. This just came all to pieces. I mean, and that kind of thing happens sometimes too, particularly like on I had a little Ford Escort that we drove when I would teach the kids how to drive. If you're going to teach them how to drive up on a drive-on lift, driving a stick in the parking lot is one thing, but bringing it up on a drive-on lift is something else entirely. I had one student that was a sort of a, I don't know, anybody that's ever done any teaching will tell you, you run across people occasionally that really should be doing some other kind of work, but because they're there, you're obligated to teach them. And this kid right here was he wasn't what you'd call not intelligent, but he had a tendency to make the same mistakes over and over. However, and I didn't get him this job, he found a job at a local tire store over there in the town where the college was. And he knew how to drive a stick, but somebody, they put him on the alignment rack, and he was doing alignments. He did pretty good for a month or so. One day though, they gave him a vehicle to do an alignment on that was some kind of an old 69 Camaro where everything was wore out and loose on it and all that. I'm talking about the clutch pedals and all. And it had this big overpowered engine, and somehow he managed to drive that thing off the lift into the front end machine and destroyed the front end machine, which I was thinking, oh my word, I'm kind of glad that I didn't get the kid the job. He went and found the job himself over there. And so they said, well, we need to put somebody on the front end machine that's more experienced than you. So they put him to work doing something else, and they hired this really experienced front end man. And the following week, and I don't know what that guy's story was, he drove a different, well, it was the following week, it was right after they got a new front end machine. He drove a different vehicle off the lift into the new front end machine and destroyed it. And so I don't know if there was, I mean, what was that guy that owned that shop must have just want to, face palm after both of those guys messed up. But I wasn't really surprised to hear that the guy that I was scared to place anywhere did that. But this other guy was supposed to have a lot of experience, and he made the same mistake. Anyway, understand your firing pattern. Now this is going to be slightly different. You can actually get a firing pattern that you can use either by probing the primary or the secondary, primary being the little wires that trigger the coils, on the ones that are set up that way. The secondary is actually going to be the high voltage side of it. The pattern is going to look the same anyway. Okay, so this is the amount of time your quote, it's all electronic, transistorized. but the points close here. But on these newer modules, they have, once they get it saturated, they're going to limit the current flow through those E-core ignition coils, because it will burn one up if you don't limit the current. The older ones would just stay, you know, like on the DuraSpark on the Forge, it was just a dead short to ground when you switch on the key. If the points were closed, who cares? Or even if the reluctor wasn't spinning on the electronic ignition, those old oil-filled coils had a dead short to ground, which was really crazy, I thought. But these E-core will not handle that. But anyway, there's your current limiting underway right there. And then this is whenever the point's open, it fires. That's how much it takes to jump the gap. But after it jumps the gap, this is while it's burning, and those molecules of fuel that are being consumed are basically being consumed right here. So you're actually going to measure this spark duration, and you're measuring this voltage too. There's actually a voltage there. Now, if you ever run into one it's starving for fuel on a particular cylinder under load, this part of it is going to get real crazy and ugly. And wow, the first time I ran into that was in 1983 at the Volkswagen place on one I was working on. It had a stopped up fuel filter on one of those KJetronic Bosch outfits. Anyway, as it uses up the fuel, it gets more and more resistance, and finally the spark burns out, because it's the molecules of fuel that are carrying the spark once the spark initially jumps the gap. Well, this right here, you need to have some leftover energy if you're actually going to have if the ignition coil is strong enough. Now, the cool thing about it is, if you want to look and see what it does to this, hook your scope up and then get your test light and hook it to ground and touch the probe of the test light to the primary side of the ignition coil. Now, you can look on my channel at this for this video called Poor Man's Scope, and you can use a test light on a plain old 2-wire ignition coil that's got a distributor, and you can watch. You can actually put that test light on that tack side of that coil where it's flickering the signal, and if it's got a pulse, you'll see what I'm talking about if you look up the Poor Man's Scope video on my YouTube channel. And I got a Bronco that I demonstrate that on. If it's pulsing, you've got an open plug wire, or a plug wire that's pulled off. But anyway, I used to take that test light and put it in when I was working on the older Forge, before they went with coil, coil pack ignition and all that. I would put that test light on there while it was flickering. The first thing I would do is I'd put the test light on there and I'd snap the throttle. If you snap the throttle and it survives a throttle snap in the service bay with that test light on there, then that means that you've got spark plugs that are not worn out. But if you put that flickering spark plug, test light, hook it from negative side to the primary side so that it's actually using up some of the energy, you'll see this leftover energy go away. Let's have a dip here. You can snap the throttle, and if it sputters and pops and cuts up, then it needs to have plugs. And that was what I did. I would also take a wet bottle, a bottle of soapy water, and I would spray it on all the plug wires to see if one of them started leaking lightning. And so within like 60 seconds in my service bay, whenever I was doing this every day, I could tell you if one needed plugs, if it had a breached spark plug wire, or if it had an open plug wire or something like that. Pretty doggone handy to be able to do that. But I'd really rather hook a scope up and get this kind of thing here. And I've got that Mix-Sig scope that I showed on one of my videos a while back. I was playing with it. I bought one of those probes from AES Wave that I could connect that with. And I'm going to do a little presentation on that later. All right. Power windows. All the time when I'm at a drive-through, I see people whose power windows are dead and they have to open the door to do business. And I was telling somebody one day, I says, if you just opened a shop and did nothing but power windows and brakes, you could probably make a living doing brakes and power windows and nothing else, Well, every time I turn around, I'm seeing somebody that's got an issue with their power window not working, and they're at the drive-through, they're having to open the door, and it may even be raining, and they're having to deal with all of that. So, power windows are, actually power windows are something I always enjoy doing. And on my Explorer, it's only got like 79,000 miles on it. But I've noticed that when I roll the driver's side power window down, it's got the cables in like they have on the newer ones. And you can hear it making these grinding, crunching sounds. You can tell that thing's on its way out. So I went ahead and ordered a good power window regulator and put it in stock out here. And I may wind up showing you guys making a video of me putting a power window regulator on the driver's door on my Explorer. That's the one I use the most, and it's probably the one that's going to die first. Alright, you got to find the right cam crank pattern if you're going to be scoping. This is a 2010 Malibu, and you know, if you're using Pico or a lot of the other higher end scopes, you can actually save the pattern, and whenever you save the pattern you can basically expand it, move these up and down, and you can compare where they are. And you got to have a good one to compare to. Just getting a cam and crank signal, you know, if you've got cam and crank signals, you need to know where these are on a good pattern. And so there is a way that you can pull that up. There is a Facebook page, if you're a mechanic, that you can get into, where there's basically have known good waveforms on there. And sometimes you can go on there and ask somebody, hey, anybody got a known good waveform for a 2010 Malibu or whatever, you know. And I've borrowed some of these patterns from there. But you know, your exhaust cam sensor, your intake cam sensor, and your crank sensor are supposed to line up a certain way, and you count these pulses. There's your missing tooth, see? And so you basically want to know, look at your missing tooth and see where these line up and compare it to the way yours are. And you can tell if they're out of time, or you know, if the cam phasers are giving trouble or something like that. This right here is one on a 2016 Escape. You said they don't all look alike, so you got to kind of know what you're looking at. And occasionally you're going to have some noise in there, but you can just blink that out. There's actually a setting on a lot of scopes where you can get rid of that noise. You can denoise the pattern so that all you're looking at is what makes sense there. And you know, usually when you get something like that, it's going to be because of an ignition spike that's being picked up by the scope, because it's real sensitive. But anyway, that's the 2016 Escape. And like I say, you're going to be able to, you know, you count the numbers of these. On the ones that had an analog pattern on the Forge, we would adjust the cam sensor so that whenever the cam was, you know, if it was a sine wave, it would needed to be crossing the center line at 8 teeth after the missing tooth and that kind of thing. You wouldn't know that unless you had that information, or you had a scope pattern on one that was set up the right way. I mean, but I could devote an entire presentation to scope patterns of this type and others and probably put you to sleep, you know. Alright, I made a homemade keyless entry trainer here, you know, using that module, and I put a box here with 5 buttons on it. I had the relays, and then over here I had basically had a little motor that would go back and forth whenever you operated that. So there was a switch there, there was it, and I actually had it where you could match the button on your fob. You know, you could program the fob, or you could punch in the code, because the code's always on that box right there. One of the dumbest things Ford ever did was they would put that code on the hinge for the trunk. And anybody that knew that could walk by when you were unloading your groceries and look at that number on the hinge for the trunk, that 5-digit number, and punch the code in and get in your car. And there were times when you could just punch the numbers randomly on the door and eventually get the thing to open. Then they changed it so that if you punched the wrong number 7 times, it would start over and lock you out, you know, and all that. In other words, it wouldn't take any more input. Anyway, that was a teaching tool I did. I got a part of an Avon box from my wife here, and this was the power that we connected to that. And I'd make them wire this up. They had to wire it up so that it would work. And that was one of my preferred methods of teaching, because Ford Motor Company was doing that one time when I went to school up there, and I thought that is a doggone good idea, to be able to use alligator clips, wires, to build the circuit so that you will know how the circuit works. Whenever you're out here trying to troubleshoot one, if you know how it works, you're a whole lot better off. Now, keeping the tools in order was something I struggled with the whole time I was a teacher. This method worked better than anything else that I used. And I basically, these Blue Point hooks I had found in a cabinet. They were bought by a previous instructor, and there was a huge bunch of them hooks over there. And then there was a supplier that actually, because I was buying other stuff, she gave me these 4 panels that were pegboards. And basically I put all of those on there, and you know, I mounted everything, and I put the size on there with so as you could tell. Now the students were better to put these things back when they got through with them. This way, if you put it in the toolbox and you have it laid out in the neat little wrench racks and all that kind of stuff, that's okay, but they were less likely to put those wrenches back where they were supposed to be on a wrench rack in a toolbox than they were on this thing. They would stand there and they would sort the wrenches out and hang them up where they're supposed to be. I mean, that just worked really smooth. And that was about the best idea that I came up with that worked best. That grease gun over there. There was a knothead one time that came, he told me he was from the diesel department, him and this other guy, the two of them students, and they wanted to borrow my grease gun, and I was under the impression the diesel instructor had sent him up there to get my grease gun, and the grease gun never came back. So I called the diesel instructor and I said, why did your students not bring back my grease gun? And he said, well, I didn't send anybody up there to get a grease gun. So the students came up there and conned me out of my grease gun. So I had to get another grease gun. I would also tell some people that wanted to come borrow my jumper box, I'd say, no, I'm going to send a student with you. You don't borrow no jumper cables or a jumper box here, because people have a tendency to run off with that stuff and not bring it back, you know. Anyway, you can replace the fuel tank sending unit. You can buy these at the Chevrolet place. I don't think any aftermarket suppliers sell anything except the whole pump. But let's say that you don't want to replace the whole pump. You just want to buy the sending unit. Now, I will say, buying the sending unit sometimes will cost you $140 or something. I don't know how much they are now. But we just bought the sending unit and put the sending unit on here. You know how these love to wear out on these vintage, you know, in the, like, you know, like I'm gonna say 97 to 2010 or whatever. They like to, the gauges like to go crazy, the fuel gauge. Of course, on those Chevy pickup trucks, those little stepper motors in there that drive the needles like to die. And you can buy a little kit off of Amazon that comes with a soldering iron and a thing to pop the needles off. And you can fairly easily, if you're a hand with a soldering iron, replace all those stepper motors on the back of an instrument cluster in one of those, you know, 00 series Chevy pickups. I've done those. They're really a lot of fun. This right here, you're going to check for wear when you get it up here. And this one right here, because if you put great big giant tires on one like this, you're going to wind up with all kinds of wear that you would not have had nearly as soon if you just left the same size tires on it. Of course, people like to go ahead and modify their vehicles and put these big tires on them and all that. One of the things I usually like to ask people is the modification you're making going to make it drive better, ride better, get better fuel economy? What's it going to do for you? You know, if you're just wanting to look better, but everything else goes to pot, you know, why are you making the modification? It's their business, it's their ride, but I'm just asking questions. And I asked another group of students one time, I said, let's say there were two 96 Chevy Camaros sitting out here, and one of them was all dolled up with the radio and the fancy wheels and, you know, all the stuff that they put on it, you know, the air you know, ground effects package and all that hogwash. I said, you got two of them sitting side by side with the same number of miles on them. You got one of them that has never been touched. This original radio, original wheel, original exhaust, original everything. Then you got another one here that somebody's got all dolled up with this, that, and the other. Which one would you buy? Almost invariably, the people said, I would buy the one that nobody had touched. And the reason they do that is because they want to decide what's done, and they don't want to have to undo a bunch of garbage that somebody else did. We would have people sometimes that would buy a Mustang or something, a brand new Mustang, and the first thing they do would be get some hot rod fuel injectors and a bigger throttle body and all kinds of hogwash and put on there to try to make it special for them. And you know, they wouldn't own the thing a month before they'd spend all that money and put all the parts in there. Then they start getting check engine lights, and they want to bring it to the dealer to get it fixed under warranty. And if I opened the hood on one of those and saw all that stuff on there, and it was an under warranty job, I'd say, look, you're going to have to put this thing back like it was, or we can't do anything for you. You know, because you can really cause yourself all kinds of check engine light issues. You know, you can do all that stuff and that's fine, but don't expect to drive around without a check engine light, because you're liable to have all kinds of issues with that. And on the diesels, it's even worse, you know, these electronic diesels. All right. Fix this if you can. The problem is, once this electrolysis begins to take over and you start to get rusty sludge and mud in your cooling system, it is very, very difficult to ever get that thing completely flushed out. You'll get it clean enough where you can drive it, but as far as getting this thing as clean as it was, where it's not attacking all of the metal parts, I'm talking aluminum, even if there's stainless steel parts in there, it'll try to attack those and they'll gall and all that. Cavitates the water pump, you know, eats the impeller. If it's a steel impeller on the water pump, it'll try to eat that. But washing, if you keep the coolant system serviced like you're supposed to, this doesn't happen to begin with. Well, when this does happen is when somebody just lets it keep on going, and then they want to wait until it gets to this particular shape here before they ever do anything about it. And you can do a heck of a lot of flushing and never completely get rid of this. There's always a continual problem after that. And it's a tremendous amount of work to get all that stuff out of there, so that I always like for it to be clean and pristine, but it never is anymore. That's like getting a grease stain on a white t-shirt. It ain't never gonna look the same again, you know. All right, this right here is caused, and I've talked about this a little bit before. You see ever see these rusty red deposits? And this is caused by Octane Booster. The first time I ever ran into this was my brother had a Thunderbird. It's one of those 375 horsepower 429s, it's a 71 model. And that thing, he was always putting Octane Booster in it because he felt like it needed it because it was a high performance, you know, OEM. And the problem he had with that was it started, you know, sputtering and popping and cutting up. And when I pulled the plugs out, I saw this red rusty looking deposits on the plugs. Now that wasn't red from rusting. It was actually some sort of red deposits that was left on there by the Octane Booster. And I'm not saying every Octane Booster does that, but I have seen several of them that do. This was in a Mustang that only had 11,000 miles on it. The guy was using Octane Booster. And you notice how this carbon tracking around the edge of this, that spark was jumping out to the side. And what it was causing on that one was a really nasty surge that could be, it was confusing because when you unplug the EGR valve, the surge would go away. Now on some of the old 3.8s, when the valve stem seals was starting to leak and they were starting to get those puffy brown ice cream looking deposits on the spark plugs, you could basically unplug the EGR valve and they'd smooth out. And it would be because they had valve stem seal issues. Well, this one right here was doing the same thing. You unplug the EGR valve, the problem would go away. Pull the plugs out, we see this garbage here on them, and I put the light on it so you could see where the spark, rather than jumping across here, was jumping to the side. And in that particular system, in that chamber, that wasn't getting the job done. It was causing it to cut out and run rough. And it was because the guy was using Octane Booster. He even told us he was using Octane Booster after we went and said, what's going on here? He said, oh yeah, I've been pouring Octane Booster in there for a while. Of course, I suspected that when I saw these rusty looking plugs. Replace the cylinder or rebuilt it? Well, what we always did whenever I worked on brakes back in the 70s, we'd always jerk them cylinders apart and we'd hone them out. If they didn't have a bunch of rusty pits in them, we'd put brand new cups back in there and brand new you know, boots on them, and we would build the wheel cylinders and bleed them out and all that kind of. That was part of a brake job. That's just what we did. Nowadays, these wheel cylinders don't cost about $10 or $11 for most vehicles, and so it's a whole lot easier just to pop a brand new one on there, because apparently they don't cost a whole lot to build or they wouldn't sell it for cheap. Pop a brand new one on there, tighten them up, you're good to go. Once you get them bled out, you got to make sure you get them bled out good though. If you don't get them bled out, you don't get these shoes adjusted right, you're going to have a lousy pedal, even if there's no air. If these shoes are not adjusted out real close to the drum, you're not going to have good solid pedal. So that's really important too. These ones right here, these had rivets right here. I worked at a truck shop where we used to re-rivet new linings on the brake shoes and all that. But that was a long time ago. All right, this right here was a 2007 Toyota Tundra. We had to pull that manifold to get that starter out of there. That was an absolute mess. It pays like nearly 6 hours to replace a starter on a Tundra. And you know, the earlier Tundras had it under the manifold, like a Lexus V6 or whatever, or V8. This one here had the doggone thing under the, you know, on the side of the engine. But man, that was a lot of trouble to replace. I'd rather pull the manifold off than have to do all the stuff these guys did to change this starter. But I mean, that's just that's a mess. See, that's where it goes, right up in there. And anyway, see right up in there is where the starter goes. And you cannot get to it without pulling the manifold. There's a snake skin you got to pull off there and all that hard wash. It was no fun. That guy lucked out. He was just a student and he said, hey, my truck won't start. Found out I had a bad starter, and we put that one on there. The beauty of the IDS power balance test, first time I ever saw this test was on the SBDS machine that Ford had. And whenever I reveled in that thing, whenever you could take the WDS, which was the predecessor to the IDS, it was like a laptop that was all built together. you could take that thing down the road on one of these cop coil Fords, and if it ever dropped a cylinder like toot toot, you know, it would give you the cylinder that it dropped out on, just like with a little track right there. That was absolutely gorgeous, and it was wonderful. And a lot of your scan tools, I've got a scan tool right now that's got power balance. Some of them have actually figured out a way to make it work on some of your other makes. So that kind of power balance, Ford came up with that, and that's some of the best power balance stuff. Of course, you can also look at the screen where it's counting the misfires and that kind of stuff, and that helps too, you know. Anyway, I just wanted to mention that. This was a broke off holes in an alternator, and it's a beautiful textbook, gorgeous dead center drill out. The student did such a good job drilling that out that I wanted to take a picture of that for future reference, because that's what it's supposed to look at when you drill a bolt. It's supposed to go right through the middle. And you keep going bigger and bigger and bigger, and then you can run your tap through there and clean all that up, and you got you a really nice fix there. All right, what do you do if it didn't come in for this? You know what I mean? In other words, if it came in for something else and you see this, you know, obviously these terminals can get to the point of where you've got to replace the terminals or the cable or something in order to fix that. But we have seen some come in like that, just a total disaster. And I always worried about that, you know, because if you let it out of there without doing something about this. Now, what I always like to do to prepare for whatever fix I was going to do on these is I would get some of this spray that you get made by CRC that you get at the parts store, this battery terminal cleaner, and I would just spray that foamy stuff all over this thing, and I would take it out there to steam cleaner, and then I would rinse all of that off, and boy, you get those cleaned up. And once you get them cleaned up and all this garbage off of them, if you've ever brushed on any of that stuff and all, it gets up here and it feels like it's in your nose, and it's just, you know, I hate this stuff. I think if you rinse it off with that water, you don't have any issues with it. Of course, you got to make sure when you're doing anything under the hood with the steam cleaner nowadays, if you get water in any of your connectors, you're going to have issues, you know. And I've seen people do that the wrong way. But anyway, that right there is something that should never be left alone. If you get it in there, you need to show the customer and say, look, you're going to be down beside the road with this or not being able to start and go one day. We need to fix this. Then you can sell them some battery terminals or whatever, you know. This was me in 1975 or 6, whatever it was, working on wheat harvest. I went on 2 different wheat harvests, and I think this was in 76. And I was the only wrench guy that they had. I wasn't but 18 when I went on my first harvest. And they would have me out here working on brakes and building engines and all that kind of stuff. And that was just a picture. It literally looked like I'm holding that truck up, but there's a bottle jack behind me over there. Of course, that's really nice and safe. You see what I'm saying? Anyway, I got, you know, somebody took my picture while I was working on that. I had the brake shoe laying up here and all that kind of thing. All right, this is really good. The on-car brake lathe, this is a Pro Cut. It is a really wonderful brake lathe because it actually sets itself. Once you get it on there and you push that button over here and let it, it'll spin and it'll actually true itself up. This has got to be mounted true or you'll make a mess out of your, you know, if you got it where it's turning that way, you're going to have this when you're stopping. This one here would automatically, you didn't have to use a dial indicator, you didn't have to make any adjustments yourself, you just mash the button and that thing, when you'd hear it going, and then it would give you the numbers telling you it was ready, and then you could go ahead and do your cut, and it was perfect every time. That one there, I think that one was $12,000, but I can't remember exactly. I bought that one at the, you see that's a brand new lift. I was over there at that new program that I started in that town down the road. But anyway, I did that. I worked that program for 2 years after I got everything set up. And that little silencing block right there on that thing. But I love that that thing, and it worked so smooth. George Gurley came to, you know, set that up for us and show us how to use it. But that's one of the handiest things I've ever seen right there. And you know, it's a terrific job. Now, the way this happened, and I think I mentioned this before, that Bronco was left sitting by a student, one of the college students. He took the stoplight switch off because it was part of a worksheet, and it came time to go. He just left the stoplight switch hanging and the brake pedal disconnected from the master cylinder. Didn't tell nobody, didn't put a sign, didn't disable the truck, and he just went on to the house. The next morning, one of the dual enrollment students got in this Bronco to back it out of the shop and somehow managed to get it in drive instead of reverse. And he couldn't stop it because the brake pedal was just swinging. You know, of course, I guess he just didn't think about feeling of the brake before he ever you know, try to go anywhere. And he panicked, and the thing just drove up under the truck and knocked his car off the lift and all that. Now that was an old Honda car that the brakes were so worn out on it that we just about had to replace everything on the brakes. And it didn't hardly damage this car at all. You'd be surprised what it did more damage to my trainer vehicle than it did his customer's old Honda car. And the customer's old Honda car, that I said, hey, you know, we had an accident, knocked it off the lift, and they said, I don't care. That's my second car anyway. I don't even really care if I don't hardly even drive it. So it was pretty interesting how forgiving the customer was, because it only had a little dent in the fender. In spite of what you see here, it looked like a total disaster. Fortunately, nobody was injured here, but we had to jump through all kinds of hoops to get this thing off of here and get it out from under there. It was a booger bear. But anyway, the student that did that wound up dropping out of the program, and I'm kind of glad that he did, with all due respect. But anyway, that was a big mess, and you know, that's makes me a little uncomfortable even looking at that picture. I watched that happen. I was over in this service bay over here, sitting in a yellow Chrysler Crossfire, when I saw this happen, and I was like, oh my word, I can't believe this, you know. But it was the actual cause of it was that knothead the previous day had left the brakes pedal disconnected, and if you got a vehicle like that, it needs to be disabled so that it can't be started and driven. And that guy that left it loose, you know, he just laughed about it and shrugged his shoulders because it wasn't his problem, although he caused it inadvertently. And of course, the student should have felt of the brake pedal. There's all kinds of shoulda, coulda, wouldas in a situation like this. But fortunately, nobody. My adjunct instructor bought this vehicle when it went up for auction, and he uses it on his farm, and it still runs and drives real good. Now it's got a 5.8 in it and a C6 transmission. It gets about 10 miles to the gallon on a good day on the highway, but it's a workhorse. All right, pin fit is a big deal on just about anything you're going to do. If you got a code, one of the things I like to do is I like to unplug that sensor, and I like to look. Also, you don't want to take a test light or a voltmeter probe and ram it down in those things. I used to tell my students, don't ram the thing down in there because you destroy the thing. And went out there, the first thing one of them did was he rammed up the leads down in there, which is exactly what I told him not to do. I don't understand this business when you're telling somebody something, they're nodding their head like they hear you, and then they go and do exactly what you told them not to do. It just makes you want to, you know, slap yourself on the forehead. This one guy says, where's my coolant going? You know, we were working on something else. I think we were getting ready to put a starter on there, but I noticed this, and we found a plastic T up there on his coolant system leaking, and it was trickling coolant. Now, he didn't even really know he had a coolant leak. He just knew it was coolant. Well, he sort of did, but he was adding enough coolant to where it didn't, you know, he didn't damage the vehicle. But I took that picture because I saw coolant running off. That's a tattletale right there when you see that, obviously. And you know, there was the shop when it was in swing, and we were doing all of that stuff. And that is a busy shop. My dad always said when you got a busy shop, you usually have a shop that needs to be cleaned, and there's stuff on the floor. And there's a passage in Proverbs that says, where no oxen are, the manger is clean, but much increase comes by the strength of the ox. I use that when my wife fusses about a mess that I leave behind sometimes when I've been doing something. Until next time, I really appreciate you guys tuning in, and we will talk again. Thank you.